Hey everyone, welcome back, and today let's solve Leetcode problem 347 titled Top K Frequent Elements. So we're given an integer array nums and an integer k, and we need to return the k most frequent elements, which we can return that answer in any order. So in example 1, we have our input array nums to be 3 ones, 2 twos, and then finally a 3 to follow. And in this case, k equals 2, which means we want to have an output of length 2. In this case, the two most frequent elements in the input array nums, which basically mean the two elements that have the highest frequency across all elements in the input array nums, right? And in this case, the output would be 1, 2. Why? Because the values 1 and 2 have frequencies 3 and 2 respectively, which are the highest frequencies or most frequent elements or occurrences of elements across the entire input array, the two highest that is, and so that's why we have an output of those values. In example 2, we have our input array nums to be 1. In this case, k is 1. There is only one element that has the most frequency. That's just the only element we have. That's just 1. So very straightforwardly, we just have an output of 1. So for the constraints here, we see that the length of our input array nums is going to be between 1 and 10 to the 5th power. Any value in the input array nums is going to be between negative 10 to the 4th power and 10 to the 4th power. And our k value is always going to be in the range from 1 to the number of unique elements in the array, kind of confirming that it is going to be valid, and it is guaranteed that the answer is unique, just kind of validating what the problem statement said, and telling us that, okay, we're always going to have a valid kind of case, which brings us to the main observations that we really need to make. And the main observation, quite straightforwardly, is we're prioritizing larger frequencies, meaning whenever we see small frequencies, we want to kind of pop them off or just ignore them because we don't care about the smaller frequencies. We only care about the larger frequencies, more specifically the k largest frequencies that we see across the entire input array. And we, at any time, as we iterate through the input array, we always want to have the k most frequent elements, or k most frequent elements that we see with, and we get that with its frequency. And how do we can solve that? With prioritizing elements. A min heap is great for that. Kind of prioritize larger frequencies and easily pop off smaller frequencies when needed for only top k most frequent elements. Right? We're always going to try to pop off the smallest frequency that we have so far, because we only want to get the top k largest frequencies across the entire input array nums. And how do we get the frequencies of elements in the entire input array nums? A very simple way to do that would be using the counter here. And yeah, we're going to get the counter. We're going to then iterate over all the different values in the counter, maintaining the k most highest frequencies at any point of time, and then finally return the values of that. Right, so the way we're going to do it is we're going to first initialize a count to just basically be the counter of our input array nums. It's basically just mapping every unique value in the input array nums to its corresponding occurrence or frequency, right, to be able to understand which frequencies are higher and which elements are actually mapped to, because at the end of the day, we don't want to return the frequencies that are highest, but rather the top k elements themselves that have those highest frequencies. And now we're also going to be using a minimum heap, and in this case, I'm just going to call it heap, and we can then kind of heapify that as well. So heap q dot heapify. In this case, we'll just pass in the heap, right? Now, in this case, effectively, what we're going to really be checking here is actually checking, okay, as we iterate through the input array counter, rather the extra counter here, basically just the frequencies of all the different elements in the input array nums, at any given time or at any given iteration, we only want the k largest frequencies, right? We only want to maintain or have the top k frequencies. And so if we have more than k elements at any time and are trying to add another element, we want to pop off the smallest frequency to make sure that we only have the top k largest ones when we only have k frequencies. And the way we can handle that is for every number mapped to its frequency in count.items, really just goes through the keys and the key value pairs in the count array. If the length of our heap, meaning the number of frequencies that we have stored so far, if it's less than k, great. We want to have at least k frequent elements. If you have less than k, we just want to keep adding, and so we're going to go heap q.heap push onto our heap a tuple of length 2, the frequency of this current element and the number itself that has this frequency, and we do this if the length of the heap is less than k, right? This may have a really small frequency, but we're guaranteed to need at least k elements, and so we're first going to have k elements and then prioritize the larger ones from there, right? Now, else, if we have more than k elements and we're considering to add this one, well, then we want to actually eliminate the least frequent element. And so the least frequent element is always stored at the top of the minimum heap. That's kind of the property of the minimum heap data structure. And so if the current frequency of the current element, if it's greater than the smallest frequency so far in the heap or in this current iteration, which we can get from heap at index 0, basically is the top of the heap, meaning its frequency. If it's greater than that, well, then this current value has a larger frequency than the smallest frequency, hence it's more important. We want to prioritize that more, and so we're going to then heap q.heap push. And in fact, I can call heap push heap pop here onto the heap, and I'm going to pass in the frequency and the number. Basically, we're kind of doing both operations in one, where we're pushing to the heap the frequency and the number that we're currently visiting, because it has a frequency that's greater than the smallest frequency so far in this current iteration, and we're also simultaneously popping out the least frequent element because it's not something that we want to prioritize. We have more than k elements, and so we want to remove this as it's the least valuable element in the k plus 1 elements that we currently have, because we want to only prioritize the larger frequencies. And effectively, once this for loop executes or once it fully terminates, we just want to extract the numbers from the heap that have those highest frequencies. So we want to return a list of every value num for every frequency and number in the heap, because again, keep in mind that heap is going to store tuples of length 2 with every frequency mapped to its number. We only care about the numbers at the end of the day. We don't want to return the frequencies, so we just return the number for every single frequency and number in the heap. So unless I made any syntax errors here, this should be accepted. This should be a valid solution, so let's go ahead and verify that. And as you can see, this really is just about as efficient as you can get it to be. So in a high level, how are we really solving this problem? We're really just first counting the frequencies with a counter, but then maintaining that minimum heap of always size k. It's going to have frequency, element pairs of length, tuples of length 2, and if the heap size is less than k, we just push onto the heap because we need at least k elements to even consider them. And then if the heap size is more than k, right, then if it's full, we have to compare the current frequency with the smallest frequency in the heap, which would be stored in the heap at index 0, and if that current frequency is bigger, we want to prioritize that more because it has a larger frequency, and so we want to replace it with the smallest one. And at the end of the day, the heap would contain the k most frequent elements, which is what we want to return the elements of that have that property, right? So for the runtime complexity of this solution, very straightforwardly, it's really just big O of n, really just iterating over each element exactly once, and the memory complexity is also going to be the same because of this count and this heap, which worst case could store all n elements, and so this is going to be a big O of n solution both for the runtime complexity and for the memory or space complexity. So if you guys enjoyed the solution and learned something new, please consider liking this video and subscribing to my channel, and without further ado, I will see you guys in the next video. Bye bye.